Okay, pre-calculus kiddos, let's move right on. I think this will be the last video. So before we start getting sad and sentimental about how this is the last pre-calc lesson of your entire life, let's just move right in and get it done. Okay, here we have a function. It is a rational function. Why is it a rational function? Because it's a ratio, right? We got a polynomial up here, a polynomial down here. We dealt a lot with these in the past, so some of what we do right now is going to be reviewed. In fact, most of it will be. We're going to answer two questions about this function. One, does it have any discontinuities? And where are they and what type are they? And number two, what is the limit of our function as x approaches -4 from the positive side? So we just have a question about discontinuities, and then we are going to evaluate a one-sided limit. And I'll show you how we can do that just by looking at this thing and factoring it. Okay, so the first thing we do, and you guys are really good at this by now, is we see, can we factor anything in my numerator and in my denominator? And that's going to tell me a bunch of information about at least number one, question number one. We see a difference of squares up here. So I hope you recognize that as x plus 3 times x minus 3. All right, if I FOIL this out, we'll get x squared plus 3x minus 3x minus 9. So the 3x's cancel out, you just get x squared minus 9. And the bottom, I look and I see that I have factors of 12 that add up to 7. 3 times 4 is 12, and 3 plus 4 is 7. And I've got plus plus there, so I've got plus plus there. I made an easy one for you. Okay, so we look at this and we say, I have factors that will cancel there. And kind of like when we were evaluating derivatives and limits, that is significant. That helps us to evaluate a limit. But let's look at these two. Let's look at the factors of our numerator and denominator. You might remember from, gosh, what was it, chapter 2, that the zeros of the denominator are vertical asymptotes unless one of them cancels with one of the numerators. Okay, so at x plus 4, the zeros of the denominator are x plus 4 equals 0 and x plus 3 equals 0. In other words, x equals -4 and x equals -3. Now, this is a vertical asymptote right here, -4. How do I know that? Because it's a factor of my denominator, it's a 0 of my denominator that is not also a 0 of my numerator. It didn't cancel with anything in the numerator. So I know that at x equals -4, there's going to be a vertical asymptote. Why don't I just write that whole thing? Vertical asymptote, which, if you remember, is a type of non-removable discontinuity. If you remember what non-removable is, it's either a jump or an infinite discontinuity, and a vertical asymptote is an infinite discontinuity, right? So it's non-removable. I cannot remove it. I cannot cancel it with anything in the numerator, okay? What about x equals -3? Well, that is a whole, okay, which is a removable discontinuity. How is it removable? Well, look, I just removed it up here. Okay, it is a 0 of the denominator, but because it's also a 0 of the numerator, I know that that is a whole or a removable discontinuity, and we will take a look at that in a graph here in a second. But we have located two discontinuities, and they happen at the zeros of the denominator. Okay, and one of them is at -4, which is a non-removable discontinuity. It's a vertical asymptote. We know that. And then at -3, we have a whole, which is a removable discontinuity. How did I know that? Because that factor canceled with one of the factors of my numerator. Okay, so that is the answer to number one. We have found the discontinuities and we know what type. Okay, and I'll show this on a graph here in a second. Number two, what is the limit as x approaches -4 from the positive side of our function? Well, what happens at x is -4? We know from here that at -4 for x, we know that we have a vertical asymptote, right? So we know that our function either, as we approach -4 from the positive side, our function is either shooting off to positive infinity or shooting down to negative infinity. Which one is it? You know what I'm going to do is I would just take my calculator and I would just substitute a value like -3.99. Okay, how about 3.9999? Okay, and if I substitute that in for x in my original function, I'll either get a very large number or I'll get a very small number, and that will tell me whether my function is approaching positive or negative infinity. And it turns out that in this case, if I plug in -3.999, I get a very negative number, which means that I can confidently say that this approaches negative infinity just by looking at what I have conceived of as a graph and substituting a value very close to -4 from the positive side, right? If I was approaching -4 from the negative side, we'd be approaching this way. Now I want to know, is my function doing that or is it doing that? And to do that, I would maybe plug in a value like -4.00001 and see if I get a very large number, positive number, or a very small, a very negative number. Okay, so let's take a look at the graph of this thing to see if we are indeed correct. And boom, just like that, we're on my computer. What is this? This is Peter Parker, the silly old meme format where you have him putting his glasses on and seeing the true reality of what's behind what he's looking at. This is the formula for derivative, which you just learned. But remember, guys, it's just the slope. It's just the rise over run. So next year when you go on to calculus and you start learning about a derivative and you have to do this thing again and you're all confused and panicking, just remember, guys, it's just the rise over run. It is the slope of the tangent line at one point on a function. And if you get scared next year of finding the derivative, just come see me. I will be happy to give you a pep talk and help you with your homework when you get to calculus next year. Anyway, let's put that away for now. Here is the function that we just did some math with. It is this function right here. I just graphed it. I also graphed the line x equals -4, this purple line here, so we could see, hey, look, there is the asymptote that we figured out for our graph. We knew there'd be an asymptote at x equals -4 because x plus 4 was that non-removable factor of our denominator. So that was the unremovable discontinuity, the infinite discontinuity, the asymptote, 3 ways of describing the same thing at x equals -4. How do we know that? Because it was a factor of our denominator that did not cancel or divide out with my numerator. But what did divide out was that factor x plus 3, which means that at x equals -3, which I'll zoom in here, at x equals -3, our function, it looks like it has a value there, but we've seen this before, so hopefully it's not too much of a surprise. Right there at that value of -3, we have an undefined value of our function, of our y value is undefined. Okay, so our function has a defined value all the way up to -3 and all the way to -3 from the other side, but right there at -3 it's undefined. Why? Because if you substitute -3 in, you have 0 over 0, which is an undefined value. Okay, so that we call a removable discontinuity because we removed it when we factored our numerator and denominator. We saw that that would cancel. Okay, so this is an example of a function that has both types of discontinuities. It has a removable one and it has a non-removable one at -3 and one at -4. Okay, so all you need to do if you needed to come up with a function that had a removable discontinuity is just make sure that it has a factor of the numerator cancels with the denominator. And if you want to have a non-removable discontinuity, make sure that a factor of the denominator just doesn't cancel with the numerator. Hope that makes sense. What else? Oh yeah, we were looking at the limit as x approaches -4 from the positive side. Well, we're looking here that as x approaches -4 from the positive side, we can tell that our y value is just getting more and more and more negative. So that's why our answer to that was -infinity. And then, of course, as x approaches -4 from the negative side, we would see that that limit, that one-sided limit, would be positive infinity. So the overall limit as x approaches -4 would not exist, since from one side it goes to positive infinity and the other side goes to negative infinity. Hope that makes sense. Okay, guys, that's it for this video. that's it for this module. You can go ahead and do those practice problems that I put out and go ahead and take the quiz and then do the the module 9 practice test and then take that chapter 9 test. And good luck. I wish you the best of luck on that, and I'll hopefully grade that sooner than later so you can see how you did. Oh, one more thing. Since you made it all the way to the end of the last video, you are rewarded because you'll be the first to know that I'm going to make a reaction video for you guys. What's this video going to be about? I'm going to make a video where I react to any memes, jokes, or otherwise interesting or funny content that you send me to my email, which is in the description below, or my Remind. If you have me on Remind, you can send it that way. So if you want, I would love for you to make a meme about the class, make a meme that roasts me, make a meme about that time that I April Fool's you guys into thinking I was doing a Minecraft live stream, something like that. Make something for me to react to laugh about. I will post a video of me reacting to it on my computer. I'll post it to YouTube. Let's see, when should I post it? Last week of school is like the 18th to the 22nd, so maybe I'll post it Monday the 18th, okay? But of course, if I don't get any memes or anything from you guys, I won't post anything. There will be no video to end the year off with, okay? I just thought this would be a fun and silly way to end the year, to say goodbye, to send you into your summer with hopefully positive memories of your experience of pre-calculus. Okay, so send me stuff. If you don't, oh well. I'll probably make a couple of my own memes to throw in there too. Also, if you just want to send me a note, you don't want to put anything in the video, but you just want to send me a note and saying what you thought of the class and saying goodbye, I would love to hear from you. So feel free to email me or send me a note on Remind. I would love to chat with you that way. Okay, that's it. You guys know that I'm still in Zoom every Monday, Wednesday, Friday from 10 to 11. I'd love to see you and chat with you and send me your memes. This is Mr. Troll, out.